Learning with us.
Okay, welcome to ICE Education, the only education that matters. Okay, guys. I took an example in the beginning of the class, where I say that let's say someone is holding your hand and someone is pulling it. What do you feel? Let's take an example of what's on the board here. They said a hole shown there is 40 millimeter diameter and long 160, is subjected to a force P and as well as torque T. Calculate the maximum direct stress and shear stresses at point A and point B. Now, the aim of this chapter, is that a question? Please ask a question. You don't have to raise your hand.
Yeah, I was asking that we can't see your screen, but now we can see it. Thank you.
Oh, you can. Okay. My brother, do you see this object here? Let me not yet move to the object. A simple example. Everything that you do, let's say you are standing, someone come and push you, you will experience a stress to your body. So that's why they say calculate maximum direct and shear stresses. Now, you have two type of stresses. If I pull your hand, what did you say you will feel? You will feel like your body will move, right? I'm bending you if I pull you.
Yes.
What happened when I turn? Let's say this is your arm and I'm turning it like this. What do you think will happen to your arm?
You're twisting it.
Yeah, if I twist your arm, like what will happen?
The pain's gonna be great. I don't know. And then isn't
Now,
that
let's say
great?
I take your hand, I turn it 360 and I keep turning it. What do you think will happen? Just think of it generally.
It's gonna hurt.
No,
I can't think.
Your arm will break because I am sharing your arm. So I'm causing a shear stress through your arm. When I pull you, I am bending your arm.
I'm stronger than that. So don't break.
You saying? Oh, you're stronger than that.
Yeah, I don't break.
Yeah, guys.
It'll only hurt.
The only reason why I'm taking my time here to explain this, because in this topic, what we will be doing, it's simply to study what happened if I put this force in this position. Am I breaking your hands or am I pulling your hands? You will notice in some other instances there will be forces that can bend you and can also break you. So I took an example I think a few minutes ago with Yaya. If I take your hand and pull you, you will still feel pain. You're gonna move. I'm bending you. So now, literally, if I take your hand and I twist it, what will happen? I'm breaking your hand. It means I am causing a shear stress. So the topic of today is called transformation of stress. That's just it. I don't know if it's making sense, but you'll see how it is done. It is not that bad. It is not that complicated. You just have to be able to see what is this guy causing to me. So, here we go. What do we need? First of all, we have two types of stresses. We have direct stress, we have three types: bending stress, and we have shear stress. A simple example is here. Do you guys see this figure here? Before we even solve the question, let me try to redraw. Maybe I'm not that good, but at drawing. This is literally it. They say it is an object attached. This is just a support. Trying to draw 3D Niana. Let me explain it through this here. It's fine. Why should I suffer? And I have a drawing here. Okay, yeah. This is the object, right? It is attached to a wall, but you have a point up here, point A, and a point B here. Now, they are saying, I just want to ask you a question. When you look at this torque, when you look at this force P here, when you look at F here, let's start picking force by force. What do you think Chi is doing to this system when you look at it? You can speak to me, Mr. Oji.
Like, it looks like it's been pulled as well as being
No,
twisted.
just look at the force T. Just look at Chi is the torque. They are even showing you that it's turning
yeah,
like
it's
this.
it's turning. They are twisting that rod.
So, do you agree? Just by the way you see him, you can confidently say that Chi will create a shearing force.
Yes.
Now, what do you think F will do, guys? You have to be able to see it because complex shape will come. What do you think F will do, my brother?
It's pulling, like it's a direct.
It is pulling.
stress.
It's creating a direct stress. So, if you want to know a direct stress, it is simply a stress acting. Let's say, I have a rod here like this, as it looks there, and I'm acting towards the rod like this. This is a direct stress. When I go where the object is, I have a compressive direct stress. It means it is negative, compressive. When I pull away, I have a tensile direct stress, otherwise positive. It is very, very important. So in this case here, you can see that force F is positive. Force F is positive. It's tensile. It's pulling away. Now, I want to ask you all the question. What do you think P is doing? Yeah. Guys, this thing is easy. There will be complex shapes, but let's understand this one first. Look at P. What do you think P is doing to this rod here?
It's bending it.
Oh, thank you, my brother. Thank you, my brother. P is bending it. Now, another thing that P is creating two movements, my brother. That's the reason why I wanted to draw. Let me try to draw again. If you can see it, it means if you can identify what all forces can do, then you are able to solve the problem on stress transformation. You excuse my 3D, but I'm trying to draw something like that, my brother. Okay, P is pointing down like this. I believe you all can see. So if this thing is bending, my brother, P will bend. Do you agree the object will, let's say it was here, it will move at a certain position here. Just
Yes.
because I'm bending. But as I'm bending, I will also be pulling. I don't know how to say it clearly. That's why I like explaining it physically. In this case, P is creating a bending because while it is bending, this object will have the tendency of also pulling. So the same force P is creating a bending. It is also creating a direct stress. Any question, guys? Please talk to me.
So we can say it's a direct stress because it's also acting on the object. Like
Okay,
with
okay.
the F.
No. I don't want to say it that way. I said we get direct when we move towards the object. P is actually
Okay.
where the object is. I can add another force acting like this, but I'm talking in a way like this is the object, right? You are coming into it because
Like in the same sort of plane.
yeah. Let's say this is 2D, right? If you look at it in the 2D, you will see a circle, right?
Mm-hmm.
Now, the direct force is the force going in,
Yes.
Like either, I don't know, this is the 2G, the force coming in like this. A force pulling away like this or like this is not a direct force. That's why you see P is coming in. It's either is like this or is like this. But as long as it's coming into it.
Okay.
Did I answer you, my brother?
Yes, sir.
Sure. So this is what's happening here. Yeah. So I know it's a beginning. You will see with couples of examples this will be easier and easier. So what are the formula that you need to know? You just need to know to calculate the bending stress or direct stress. Here's the formula of calculation. Just couples of formula. That stress is given like this. Rho is equal to my over I, where m is the moment of the force that is applied, y is the distance from the center of gravity, why in this case basically the radius of your rod.
Please say that again, sir.
Okay, I will show you 2 examples now, don't worry. Hey, Mr. Oji, why do you call me sir, my brother? Okay, what I was saying, the distance y.
You are.
If you have a rod, my brother, right? A rod, remember you are given a diameter and length. The diameter is the circle. The length, let's say, is from here to here. But the diameter, we talk about the circle here. The y distance is simply the distance from the center of gravity of the rod to any point, to any corner, which is basically the radius. That is what we call y. So in simple way, y is simply the radius of your rod. If you are given diameter 40, definitely my y should be what? 20. I hope I'm making sense. So what is I? You also have the formula for I, moment of inertia. I is equal to pi over 64 diameter to the power 4. So these are the formula that you need to know. You also need to know that direct stress. Please name the difference. All the bending and direct, they are named as rho like this. Direct stress is equal to force over area. So all the direct stress are the stress causing by the force what? Acting like going in or going out at the center of the circle. Those one are the direct stress. Now, what is next, Yaya? We also have a formula to get the shear stress. Shear stress is written like this, tau. It is torque times R, which is also the radius as well, divided by J. But J here is what we call the polar moment of inertia. The formula of J is simply pi over 32 diameter to the power. Yes.
Did you say pi over 64 or C4?
Eh, Scalas Banning, key 64.
Okay.
Yeah, key 64. So, my guys, these formulas will be the ones that you will be using throughout this chapter. So, we can do these things without thinking. Let's look at case A. They said calculate, and again, you need to remember some couples of formula that we use in diploma. Let me just recall them for you. It basically says that formula of direct stresses and maximum stress in strength 2 or strength 3. We did something like this, but let me write it down for you. I don't know if you remember this, but I'm just gonna recall it for you. It's not that bad. You will see when we do them. Okay, they said stress and rho 1 and 2 is equal to half rho x plus rho y. The good thing about plus minus or plus, yeah, plus minus half the root of rho x. The good thing about this topic, my guys, it is a topic at which you have to be able to see that once you picture what you are doing, you cannot fail it. So it's a matter of seeing what you are doing. Rho xy square. Again, I will send you a picture of this formula. I will send you a picture of that. And they said maximum torque, rho max, is equal to half, where is it again? Half rho 1 minus rho 2. So yeah, these are the formulas that we will be using throughout this topic of stress transformation. So what you need to
Sir.
do, yes boss?
What's that last term under the square root on the first formula?
On the
It's
under the
plus. Yeah, on that.
here,
Yeah, there.
or
Yes,
it is
sir.
rho xy. Rho xy is simply the shear stress.
No, but then what does it say? Plus
No.
4 what?
It is 4 times t square xy. Torque square, which
Oh.
is simply the shear stress here square.
Oh. Okay.
Now, guys, these are the formulas. Usually when we do this, it is important to recall axes, guys. Remember, this is a 3D shape here. Yeah. When you have a 3D shape, yeah, there's a lot of geometry here. I can pull this like this as one axis. I can pull this like this as another one. I can pull this on top as the third one. So you can call them X, Y, Z. Something like this. But don't worry, I got you. You got ICE education. This should be easier. Now guys, let's look at case A. On case A they said calculate the maximum direct and shear stress at point A and B if case A they say, in case A we said F equals 0 kilonewton, P equal 3 kilonewton, and T to be equal to 1 kilonewton meter. So now guys, in case A, if F is 0, do you guys agree that when it comes to calculate maximum direct and shear stress at point A and B, that we don't have a direct stress? Because we know that direct stress is equal to F over A. But if F is 0, it simply means this will not exist. I guess we are together on this one, yeah.
Yes, Ice.
I remember.
Sorry. I was called out for just a few minutes. I'm back.
No problem. It's fine. Mr. Lungelo, are you with me, my leader? Okay. Koto.
Yeah, we're together, Ice.
Sure, my brother. Now, it simply means the only thing that we have here is the bending moment. Is the bending moment. Now, what is happening here? We have P, which is causing the bending moment. So that bending stress, we said it is M multiplied by Y divided by I. So what is M? Very, very important again. Everything is being played where the figure is. This force, remember, we are doing this study according to the point A and B. So A and B are our reference point. Remember, the length of the road is 160. 160 means it's from here to here. 160. So the perpendicular distance to it is the force P. So if you do force times perpendicular distance, you get the moment, which in this case is 3 multiplied by the length, which is 160. So in meter, 0.16. I think is 3 kilonewton should be 3 times 10 to the power 3. Yeah, Vilakazi.
Sir, can you please repeat?
Oh, who's calling me sir again? Okay, we do know that.
Can you please repeat?
No, it's fine. Even say it's fine. Maybe I'm meant to be say. Let's say you have a reference point here, CC. This is the distance, right? L. This is the force P. Let's say, what is moment? Force time perpendicular distance. So moment in this case will be the force P multiplied by L. Now, this is the same thing that is happening here, but it is in 3D now. This is 3D, this is 2D. Where P is like this, the perpendicular distance is from where it is to where this object is here. So, force times perpendicular distance, that is what is making the moment. So, what is the force P? 3 kilonewton. 3 kilonewton is 3 multiplied by 10 to the power 3, right? Multiply. What is the length? The length of the road, they say it is 160. So we definitely know 160 meter is 0.16. So everything over, what is I? I, we say it is pi over 64. Yeah, don't mind me, I'm just calling your name. Pi over 64 multiplied by the diameter square. What is the diameter? 40. What is 40 in meter? I guess it is 0.04. Please double check for me if I'm not mistaken. Sisi, did I answer you about the moment?
Ice, we can see your screen, or is it me only?
Guys, can you see
You
my
can
screen?
see it.
Hey,
Maybe it's my network, okay.
Lungelo, no, don't say it's okay. Try to log in. How do we say it again? Log out and come back.
Yeah.
Try to
Yeah, I think it's my network. I'll do so.
Any question here, Sisi?
So, Ice,
Yes, brother.
the formula for a maximum direct stress will always
This is
be
the formula
force
of
over area.
maximum direct and shear stress. This is what you use to get the maximum. It is this formula here, where you have rho 1 and 2. So you need these stresses here that you will bring inside here to get the maximum at the end. So for now, what we are doing, we are simply finding what are the stresses, what are these forces. You see the force applying here. What stresses are they doing to this specific object? That's what's happening. Now, the study is being made between point A and B. You see point A, you see point B. Now they are trying to say, my brother, a simple example is your hand, right? If you have your hand and I'm doing the study on your shoulder, if I pull your hand, you feel the pressure on your shoulder, right? No, that pressure, when I pull it, I exert what is called a direct force. So definitely, you have to feel something on the shoulder there. The same hand, if I bend it down, you will still feel some pressure on your shoulder. We are still asking, on that shoulder, what is happening when I bend it? Okay, this guy will be experiencing a bending stress and also a pulling as well. Now, the same hand, my friend, if I twist it, if I keep twisting your hand, what do you feel on your shoulder? You'll notice that you'll be having this, what is called in English? dislocated bonds.
So, meaning your point B will experience compression.
No. Wait. Ask your question again. I need to understand you.
If we are looking at the force P
If
with
I'm looking
respect
at
to
the
those 2
first,
points,
yes.
with respect to point A and B.
Yeah, that's one of the reasons. One will be having positive, one will be having negative.
Okay, so I'm asking if point B will then experience compression,
It will
and
experience compression, yeah.
point A will experience tension.
Yeah.
Because it's going
That's
to be pulling
definitely
out.
it. But they will be at the same magnitude. Okay, I don't know if you understand his question. Remember, the studying here is being made. We are trying to find what happened on top here. What do you feel? And what does this guy feel? The truth is, whatever this guy feels, this guy will feel the same, but with opposite direction.
All right.
So it means if A is feeling 10 Newton, B will also feel 10 Newton, but in the opposite way. For just saying negative, if I can say it like that. But the other thing is, I want to ask a question. Do you understand what's going on, guys? I know this topic, doing it online is not a bit complex, because it's something that you have to be able to see, and usually I like it contact, but I know you guys are busy during the day, so I will make my effort to explain it as easy as I can and you understand it. But so far, do you understand what we are doing, guys?
Yes.
You're the only one speaking, my dear. Yeah, do you understand me?
Yes, sir.
Yes.
Okay, my guys, don't think too much about it. What we are doing here, if you can just relate it as easy as it can, is what happened when this guy touched me? What happened when this guy pulled me? What happened when this guy turned my arm? That's basically it. So in this case here, if we do this calculation here, what do we have as answer of the bending here? It is 76,39 MPa. Now we have written what this guy here is causing. Is causing a bending. Now, what is this torque here causing, Yaya? What did we say in the beginning? Why do you think the torque is causing to this guy here?
So I don't know. I'm not getting that answer on the calculator. But
type again,
you can
please.
continue.
No. Do type. Don't say. Type it the way you see it. We have to get it. Please check 40 millimeter in meter. I'm not sure if it is 0.04 or 0.004. Divide by 1,000. What do we get? 40 divided by 1,000. Yes, it's 0.004. Now you need to get this answer, Mr.
Okay.
Ice.
Now, something is wrong. We are missing something, my brother.
It's the ice.
Yes, bro.
So are we done with that one? Because I see maybe we don't have the value of y there.
That's what I'm saying. Something is missing.
Oh.
This one, it is force times perpendicular distance. It makes the moment.
Yes.
This makes the moment. Now I say y is simply the radius. In this case, if the diameter is 40, radius key 20 in meter, it should be 0.02. Now you got the y, which is this one. You got the moment, which is this, and you have the I. Now I'm pretty sure we should get the answer that they are getting on the textbook here. Try again, Mr. Oji.
Yeah, I'm trying, sir.
Ice.
Yeah. No, it's not yeah.
It's not. It's okay. I think I missed some information. You said what's why again?
Oh, I said y is simply the radius. Okay, remember, this thing is 3D, right? It is a road, right? But when you look at a road, it goes like this. It has a diameter and it has a length. Sorry. Y is simply the distance from the center of the road to any point where the circle is, which is basically the radius.
Okay, thank you.
And you will always be having a road, or you'll be having other cases, but we'll do couples of examples. Thank you, CC, for asking. I appreciate your participation. Yeah. Are you guys with me, guys?
Yes, we are.
Okay, now can we check this force here? What is it creating? Just look at, okay guys, what I want you to do when you are doing this topic, just look at that force and what do you think it is doing on your point of study.
Which one are you asking about, sir?
Remember, my brother, we check for F is 0. It is 0 here.
Okay.
We check for P, we get a bending stress, which is also creating a direct in this case. Now, we are checking for T. Look at T, and what do you think is happening?
Yeah, it's twisting. Shear
Because it
force.
is twisting,
Shear stress.
it simply means that we are having what? A shear stress. So simply here, as easy as it is, you can come and say shear stress is equal to torque. Why am I writing the formula again? Torque times R, which is again the radius, divided by polar moment of inertia. Sorry. What is torque here? Torque Q1 kilonewton meter. Guys, okay, I think something is coming to my mind now. What do you think? What does the unit tell you here?
Which one?
When I'm looking at chi here, it doesn't matter where I'm. Do you see chi? Check the unit of chi. Kilonewton meter. Okay.
It's force times
Distance.
distance.
What is force times distance, my brother?
Moment of inertia.
No. Force times distance is simply a moment. Like basically, when we had P times the length, it gave us what? The moment M. Now, the simple reason why I'm recalling this unit here is you will see in other example, which I will cover with you, you will see that certain forces will create a shear forces. But that's for another example that I will do with you. But the only reason why I'm bringing it to your attention is you can just look at the unit. The unit tells you that the guy here is a moment. Is the moment that is creating the torque which is here. And again, don't worry about it. I will take an example to explain it clearly. How a case where a force can create a shear stress. But don't worry about it much. It was just something that popped in my mind. When I teach, if something comes in my mind, I always like to share so that when we reach that point, you get me as we move. Now, what is torque? Torque is 1 kilonewton. Kilonewton to Newton is 1000. I guess we're good with conversion. What is R? R here also simply stand for the radius as well. So key 0,02. CC, what is J? Key polar, yeah, key polar moment of inertia. Yeah. Key pi 32. Multiply by d to the power 4. What is d here? 0,04. Okay, guys, I believe that you guys can make the difference between I and J. Last year, people made confusion when the lecturer marked. I don't know how. You use J when it comes to shear stress. You use I when it comes to bending stress. Are you with me, guys?
Yes.
Now, if we do this calculation, I do believe that this guy, if you check the answer, it is 79,58 MPa. Now, you will notice here on the formula before, for us to get the maximum stress here, we need to solve for this stress and this. So under these stresses, we've got rho x, rho y, and we've also got rho xy. The rho xy will always be your shear stresses. Your rho x and rho y will always be your bending stress and direct stress. Now, what is important is to know which one is rho x and which one is rho y. Very, 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 very important area. Let me just check how much time do we have left here. Yeah, 10 minutes is a lot there. A lot can happen in 10 minutes. Are you with me, guys?
Yes.
Okay, Mr. OG. So far, so good, right, guys? Now, what we
Sir,
need to
I have a question.
Yes, boss.
That formula with the long square root, that last term, is it rho or
It is
is it
shear
tau?
stress xy square. Do you know why we call it xy, my brother? Because as this thing is sharing in both axes. That's why I said your rho xy will always be the shear stress. Now, what is important to us is to find out what is rho x, what is rho y. That's what I'm about to explain. Did I answer you first here? I think this was the question.
Yes, sir.
Okay. So here we go. Yeah, this is where we define the axes as well. If you remember earlier here, I have drawn some couple of axes here. Now, I usually like calling x-axis moving there. Yeah. This is x-axis. This is y-axis. Key 3D. And this is z-axis. I think you guys know when we talk about 2D Cartesian plane, we say it is X and Y. When we have 3D, we have the three planes, X, Y, and Z. Now, remember, Yaya, what did we say? This first P here, we're going to do the study at 2 points, at point A and point B. That's what the studying is doing. At point A, I mean, that's what the question is asking. Let's see what's happening, guys. When we are at point A, let's start at point A. We are solving for row 1 and row 2. Remember, the formula is on top here. What did I say, my guy? The first P here it is bending this object down. It is also pulling, tensile is pulling this object here at A with the same stress. That's what I say. This force here will create what we call a bending and direct stress. That's one of the reasons, because the tensile force will be moving in the X direction. That's the reason this guy that we solved here, the bending here, we are calling it rho X, because it is also created a direct stress going in the X direction. I need to ask a question there before I proceed.
Can you kindly repeat?
Thank you, Sisi. Thank you. I like the question. I like repeating. Okay, Sisi, let me try to draw something. Hopefully this time I get that 3D right. No, wait, you guys can see me, ne? I think
Yes.
if I open my face, you can see me if I explain this. Can you see my face? Sure.
No.
Okay, I cannot show my face if I'm sharing the screen. No, now you can see my face. This is literally what's happening. Do you see my calculator, Yaya? This is point
Yes,
A.
I can.
This is point B. Now, what do you see when I pull down? This thing has a tendency, as it is bending. Okay, let me use a pen. This is my pen, Yaya. No calculator. It's calculator. This is the object as it is. If I pull down, do you agree that this thing is bending? It is also pulling this side.
Yes.
So that's the reason that bending force is creating a tensile in the X direction.
Okay.
Do you no no need? Do you see it looks up?
Yeah.
Yeah. Let me close this link and return a new one. We continue this question. Okay, let's go. Okay. Here we go. Yeah. Hey, why am I losing it? Okay. Do we all agree that this bending stress is basically a direct stress of 76,39 along the x-axis? Do we have any bending stress pulling, let's say, around the y-axis? Is that someone joining? I need to edit this video, and I will send the yesterday videos later. Later today. Why am I saying today? Tomorrow morning around the AMs. Now, what is happening, guys? There's something that I wanted to ask. Let's say the same figure here, I had a force here. Let me call it force ice. It's my name anyway. What do you think ice is doing here, guys? Do you agree that ice will be bending this thing here, but do you see the direction?
Yes, sir.
No. I want a force that is bending but is pulling this thing in y direction. I don't think this is the right one. I don't know if you see what I'm saying, Mr. Ochi.
Yes, I
Remember, P
see what
is
you want
here.
to do, sir.
P is pushing down, but is pulling this thing here. So I don't know. Let's see if this force is pulling like this. Wait. Let's do this. Let me
Yeah,
bring
doesn't it also push in the y direction?
Oh, it's pushing the y, ne? When you look at it, ne?
Yes.
Yeah. It's pushing this object going like this. Tensile, but in the y direction. So in this case, this bending force is creating the rho y. But under this example that we have here, Mr. OG, rho y is equal to what, Mr. OG? Under
To 0.
is equal to 0. We do not have any bending causing a stress, a direct on the y. Easy, ne? Yeah. So if rho y is 0, rho y is 0. So we just come to the formula here. At point A, what are we going to have? We're going to have half. What is rho x? 76,39. Remember, rho y is 0, so it will not exist here. We go again. Plus minus half root. What is rho x? Rho x is 76,39. Minus, okay, we don't have rho y, so don't bother yourself. Rho y is 0. So we have this square. Plus 4. Remember, the shear stress is called rho xy because it is shearing in both directions, in x and y. That's what I'm saying. When you're having a torsion, when I'm turning your hand, you feel it everywhere. You feel that pain here. So the shearing stress here will be times 79,58 is it to the power square. You close the root here, my guys. You will be having rho 1 and rho 2. Remember, it is plus minus. Can you take your calculator and give me the answer with plus and give me the answer with minus? Yeah. Vila kazi. Guys, please, let's move. We need to do both cases and what? I want us to finish.
With the plus is 126,46.
126.
Yeah, 126,47.
47 megapascal. Positive mean it is tensile. The other one is what? Rho 2 is what? With the negative.
Yeah, let me do it now, sir. It's negative 50,08.
Negative 50,08 megapascal. Yeah. This simply means, you can write 50,08 MPa, and you put C to show that it's compressive. Both ways is the same thing. Now, there is another formula to solve for maximum direct and shear stress, which is this one. Share of mass. I'm trying to write it to make the difference between the shear stress. They write it like this. Where the formula, if you remember the formula I've given it to you, it is rho 1, 126,47 minus of the formula and the minus 50,08 divided by, is it by 2? Let me see the formula. Yeah, by
2.
Yeah, if you do that, you have solved for that rho max that you're talking about. So here, the rho max that you're talking about is equal to what?
$176.
Oh, they got 88. I'm not sure. What's the mistake?
They got
88.
Oh,
I'm also getting
yeah, I
88.
didn't divide by 2, so it's 88.
88,27 MPa. Now, my brother, that is what's happening at point A. Now, at point B, this is what's happening, my guys. The stress that A is experiencing, B will also experience it, but in a opposite direction. So what does that mean, Yaya?
It means it will be a negative sign for the maximum.
Not for the maximum. It means the direct stress at point B will be negative.
Oh.
Any question, Yaya? Do you guys understand why when we are at point B, rho x will be negative 76,39 MPa? Yeah. Are you with me?
Yes, I am. Yes.
So at
But I can see you all said there's compression at point B and then tension at into.
okay,
Point
let
A.
me just show you my face again to see what I'm trying to say. Yeah. Let me stop presenting and show you my face. I'm still gonna take again the calculator. As you pull, this goes down. The force P is going up. Look. This is going like this. This is going like this.
Yes.
So at A, it's tensile. At B, it's compressive. So that's the reason that the same force that is creating the bending is positive on top, negative at the bottom.
Okay.
That's just the reason. Maybe you wanted to see my face. Yeah, I'm sure you understood.
Thank you.
I'm kidding. Okay, guys. Yeah, that's literally it. So what are we gonna do here? Under this case, we're gonna apply the same formula, but the difference, I think, is the same thing. We'll have again for point B, rho 1, 2, half. Now where there is x, we put minus 76,39. Again, plus minus half the root of minus 73. Remember, it is square, so it's still gonna be positive here, so it's not really affecting much what is inside. Plus 4 times 79 comma 58 square. If we do this here, also gonna get row 1 in this case and row 2 in this case. What is row 1 and what is row 2? Also, are you with me?
So the calculation of row 1, are we always going to take the
Yeah,
positive
the
sign?
positive one. as
Like in
row
the
1, yeah.
equation?
Mm.
Yes?
You take the positive as your first choice.
Okay.
Good question, yeah.
Right, 50,08.
50,08, yeah. Let's try to do it quick, guys. The next guy, let me check the answer that they got. The next guy, they are getting negative 126. It's basically the same thing, but
Yeah, with opposite signs.
that's at the end you still get the same answer. So that's why.
Yeah, it's also answered that will the maximum.
The maximum
shear-
will be the same. The only difference now, you start with 50,08 minus 126,47, but which is the same thing.
Yeah, because I asked earlier, say that won't the sign also be negative for the maximum? And
No.
so in other words,
In
it
other words,
won't always be it won't always be the same. That's what you were saying.
no. Can you
It's
repeat
just
what
it's
you're
just
saying?
like what you asked in the beginning, that what's going to happen at point B.
No,
And then
but at
I
point
said-
B, you can
And
see
then-
the direct stress is negative, but at the end they are both feeling the same maximum stress.
So my question is,
Yes.
it's the same. It's not even negative. It's also
No,
positive.
they are
The
feeling.
maximum. So at point B, the maximum shear stress is also positive 88.
It's positive 8, but remember, this is what they are feeling as maximum, but the direct stress acting at point B is negative.
Oh, okay.
Now there is a question. Remember, this question has two parts. The first part is when F is 0. Now, what do you think at B will happen if F is equal to 10? Just think of it. Remember, if F is equal to 10, it means we have the presence of this force here.
Yeah, we're going to have a direct.
A direct in which direction? Positive or negative?
In a positive.
Now, how do you think you will solve? Okay, this I want us to. I'm just speaking. I will write it down, but I want us to be in the same plane with this one. Now, my brother, what will be the difference between what we just solved and that new one with the new case?
The difference will be there will be now.
Okay, the only difference here, guys, remember, you have a direct stress that is created by the bending, which is positive. Now, you have a positive direct stress that is straightly created by this force. Very straight. I don't know if you see it.
Yes, sir.
So in this case, your rho x will be the direct stress created by the force plus the direct stress. I'm losing it. Yeah. Not losing it.
Oh,
my
it's
voice.
going to be plus the bending stress.
Plus the bending stress. What is the force times area? So it's going to be 10 times kilonewton times 10 to the 3. What is the area of this thing? Remember, when we are talking about area, what are we looking at? We are looking at the diameter of this circle here. It is a road, but the area we only talk about the diameter. Which is what? What is the area of a circle, guys? It is pi r square or pi over 4 diameter square. It is the same thing. So you'll have pi over 4. What is the diameter? Diameter is 0,04. Is it square? Eh? Square plus this 76,39. Yeah. This is what makes our new rho x. Any question, guys? Please talk to me. Yeah.
Yes.
Are you with me? Are you guys with me? Mr. Ezekiel? Are you with me?
Yes.
Okay, now, if you understand what is going on here, it means that we are together. Why am I saying that, guys? Everything that you'll be doing for case A and B will be the same, my brother. Now, what you will do, you will still write the same formula, but what will change is the rho x that you substitute will be new. Now, I have a question. What will be the rho x at point B? What do you think is going to be? Think about it.
What's the question, sir?
The question is, what is the rho x at point A? We say that the rho x at point A will be the sum of direct stress created by the direct force plus direct force created by the bending. Are we good with that one?
Okay.
At point B, what will be the rho x at point B?
It will be minus now.
Oh,
It will be
thank you. So at point B, rho x will be minus, which is 10 times 10 to the power 3. You can always calculate the side to avoid writing like this. Pi over 4. Diameter 0,4 square. Minus, this is plus, sorry. This is positive. Minus 76,39. Now, you will notice something. In this case, if you redo this procedure, remember, everything is the same under this formula. What you'll be substituting is simply your new rho x on both sides. In the new cases, if you write it down, you will see that the answers will be different. You can just try. Let's try to substitute. Can we do a quick substitution, Mr. OG?
yes, sir.
Let's just substitute. What is the new value of rho x?
Rho x at point A.
Yes, let's just substitute and see what are the answers. I'm sure, but they will be different.
It will be It will be 79,58 MPa.
That is what? That is the total rho x.
Yes, at point A.
No, they are getting 84,35.
84.
Yeah, remember, rho x is 79,39 plus
Oh, it's 79, not 76. So yeah, 79,
no, it's 76 plus 39 plus the direct stress created by the force, which is the force over the area.
yeah, that's what I did, sir.
So when you add both of them, what do you get as answer? When you add 76 plus 76,39 plus that, what do you get?
I get 79,58.
Let me try on.
Wait, the formula will be, it's 10 times 10 to the 3 divided by pi over 4 times 0,04 squared, right?
Mm.
Yeah, that's what I did. I still get 79,58. I'm not sure, sir.
Okay.
Okay, let me do it because I was doing it in one line.
We are getting 79,
Plus. You said what's the answer you are getting, sir?
now I'm not getting. The book is getting 84,35.
Or 80. You said that the area of a circle is pi over 4 d squared,
Yes, bro.
and then what's our diameter? Is it 40 millimeters?
Yeah, it's 40.
So I'm still getting that answer that I'm getting. I don't know what I'm doing wrong.
No, you're not doing anything wrong. Let's do it. Let's do it together. Let me write down. Let's do it together. Let's do case B. Case B, we do have the force to be 10 kilonewton. So the stress should be force over area, where the force is 10 times 10 to 3. Area is pi over 4. The diameter is 0,04 square. What is the answer here, my brother?
Let me do it again.
Here you get 7,96 MPa. Now, the direct stress X will be the combination of the 7,96 plus the direct stress created by the bending, which was 76,39. First, Mr. OG, are you getting this answer?
Yes, I'm getting that answer. Oh, you know what I was doing, sir?
What was it? What were you doing?
My conversion was wrong.
Oh, no stress. So pay attention to that then.
Yeah.
So what you get as your new rho x is 84,35 MPa. Now, my brother, if we get the new rho x, what do? That's what I was saying, that if we get the new rho x, what do? We just substitute like we did on the previous one. Do you see that, Yaya?
Yeah, bro.
Yeah, you just substitute, you will get rho max as well. So I was saying at point B, I was just insisting because at point B, this is at point B, what will be the rho x? Rho x will be this force here, which is 7,96, now minus 76,39. If you do this at point B, you should have minus 68,4 4-3. So this is why I was saying, Mr. OG, in this case, where the direct stress is applied, the maximum stresses will be different at point A and point B.
Oh, okay, sir. Yes, I
You
see
see,
it now.
it will change because rho x here is different from rho x here.
Mm-hmm.
In the previous case, rho x there was the same as the other one. So guys, this is where I think we'll stop as tonight. It's our first class. I'll come with a couple of examples on this one. So tomorrow, what are we doing again?
I don't know. Let me double check.
Let me check the
Where's
picture.
Mr. Manager?
Hey, my manager, I don't know, he's telling me he's have power problem. Oh, tomorrow is heat, ne? Yeah. Key heat.
Mm.
Yeah, I will prepare and we do it. So far, how are the classes, guys? So far, what we are meeting? Please be honest with me. I really wanna I'm giving my best, but I wanna do better.
I believe you're doing well.
So I will send you the pictures. Let me just send you the picture of the next example or what. It's gonna, yeah, that's what we'll be doing next on Solid. But again, guys, we are moving subject per subject like this because we don't know the test date yet. But what will happen is there will be instances that we'll try to prioritize according to what is coming first. I don't know if that's fine with you.
Yes,
Yeah,
that's
it's fine.
Yeah, but for now we keep the timetable as it is. Thank you, guys. Tomorrow I will see you same time, same venue.